In this video, we'll take a quick look at problem number 69 from out of section 3.3. And this is one of the only story problems that I asked you to look at in this section. We're going to move this direction big time in January when we start looking at optimization. This is actually the first of many optimization problems that we're going to look at. And basically optimization is just any type of problem where you're asked to find the maximum value of something or the minimum value of something. In this case, we have someone who's standing X feet from a wall, and they're looking at a painting, and we know that the height of the painting is 2 feet, and we know that the person's eye level is 5 feet. So the person's eyes are 5 feet off the ground, the bottom of the painting is 6 feet off the ground, the top of the painting is 8 feet off the ground. What we can do here in order to find the value of X, or the distance this person needs to stand backward from the wall so that this viewing angle is as large as it can possibly open up to, is we're going to need to develop a formula for A, the viewing angle, and if we can then find the absolute maximum for that formula or for that function, we're going to then have the value of X that makes the viewing angle as large as it can possibly be. So what I'm going to do is I'm going to hopefully recognize the fact that this is not a right triangle. So I can't really use SOHCAHTOA or anything on this triangle directly. What I'm going to do is I'm actually going to drop this vertical line down a little bit farther and then I guess I can't really turn it like that. I'm going to have to come straight across to the person's eye level just so I can get a right angle involved there. And then this big angle is not really the viewing angle, so I'm going to specify this to be the angle B. Okay, so what I'm going to try to do is I'm going to try to develop a formula using SOHCAHTOA that's going to be a summation of the angle B and the angle A. And if you think about what you know on this diagram, and if I draw the triangle off to the side here, just to kind of get it out of the picture, we know that this is 1 foot. That's the distance between the person's eye level and the bottom of the painting. This is 2 feet. That's the height of the painting. We do know that that's a right angle. We called this the angle B, and we were told that this was going to be the angle A. If I look at this big outer triangle here, what I can say is I can say that this big angle, which is going to be A plus B, can be related to this side and the distance this person's going to stand from the wall, which, remember, was X as specified. These variables can be related using, well, the hypotenuse of the triangles here. So we have opposite of this big angle, and we have adjacent to that big angle. So opposite and adjacent would be the tangent ratio. Tangent of the angle, A plus B, is going to be equal to, well, O over A. And opposite would be 3. You have to take the sum of those. And adjacent would be X. What we want here is we want a formula for A. So now that we have a relationship between all of our variables, we can go ahead and we can try to solve this for A. And the first thing we're going to have to do is get the A out of the tangent function. So I'm going to have to take the inverse tangent of each side, and that's going to leave me with A plus B equals the inverse tangent of 3 over X. And then if I want a formula for A, I'm going to have to subtract B from the other side. So my formula for A is equal to the inverse tangent of 3 over X minus B. Now this is a little different from all of the absolute maximum problems we've done before because, yeah, it's a story problem, but now what we're running into is we're running into a formula for something or a function for something that depends on 2 other variables. It'd be nice if this right-hand side only had X's in it. Right now it has X's and it has B's. If you look up at the diagram that we have right here, this bottom triangle is also a right triangle, and it involves just the angle B. So we can actually use this bottom triangle to develop a relationship between B and X. So I'm going to do that up in the corner here. On this triangle, here's the angle B, and I'm just looking at the bottom one now, right? So I'm thinking about the top part not really being there. And if I just look at this bottom triangle, I have the angle B, I have the opposite side, I have the adjacent side. So opposite and adjacent is again going to rely on the tangent ratio, and it's going to be tangent of the angle B, and that's going to be equal to opposite, which is 1, over adjacent, which is X. And so what we can say in conclusion here is that B is going to be equal to the inverse tangent of 1 over x. So if I replace the b that I had down below with what we now have determined b is equal to, then my formula for a is just going to be a function of x. So my formula for a is going to end up being the inverse tangent of 3 over x minus the inverse tangent of 1 over x. And basically what we've done is we've turned this from a story problem into a problem that says, hey, here's a formula, here's a function, find the value of x where this function attains its absolute maximum. Because if we can do that, then what we've effectively done is we've found the maximum viewing angle, the value of x, the distance this person needs to stand from the wall in order to establish the maximum possible viewing angle. So to find an absolute maximum, it can either be at the end point of an interval, and we do kind of have an interval here. You know, this person can stand right up against the wall, but then there's not really going to be an angle A, so I guess the smallest value x can be a 0. The biggest value can, I guess, theoretically be infinity. So we don't really have a nice little interval here. So it's probably going to be the case that the absolute maximum occurs at a critical number, either a spot where the derivative is equal to 0 or a spot where the derivative is undefined. And to find either of those things, we're going to need to have the derivative in place. So we're going to have to take the derivative of a with respect to x. And to take the derivative of a with respect to x, we're going to have to use a formula from chapter 2. The derivative of inverse tangent was 1 over 1 plus x squared. This is going to be a little bit different than that, because we're going to need to use the chain rule because we have more than just an x inside each of these inverse tangents. So I'm going to have 1 over 1 plus not just an x squared, but what we had here as the inner function, which was a 3 over x. And then what I'm going to have to do to finish off the chain rule is I'm going to have to multiply by the derivative of the inner function. And the derivative of the inner function, and keep in mind, this inner function can be written as 3x to the negative first. The derivative of 3x to the negative first, if you multiply by the negative 1 and then subtract 1 from the exponent, it can be written like this. And then if we take the derivative of the second component, whoops, it's not plus, it's minus, so just let me scribble that. So minus the derivative of the second piece, and similarly we're going to use the formula for the derivative of inverse tangent. So 1 over 1 plus x squared, but we're not just going to put an x here, we're using the chain rule, so we're going to leave the inner function there. And then we're going to finish the chain rule by multiplying by the derivative of x to the negative first, which is going to be negative 1, x to the negative second. Now what you're going to attempt to do is you're going to attempt to figure out when this derivative is undefined, and you're also going to attempt to figure out when this derivative is equal to 0. And if we find those things, we should be able to establish what value of x gives us the absolute maximum value for this function. I'm running out of time in this video, so I'm going to have to do another video to finish this up. So I'll be grabbing a graphing calculator to help me set this equal to 0 and figure out where it's undefined. I'll finish it